Kia ora Year 12. I'm going to start doing the exam papers from 2021 over the next few weeks, and I'm starting with question 3D of the Level 2 Algebra exam. So this is a question that was about the area of a house built, designed to fit inside a parabola. How convenient. And it's got two parts. The first part where we have some specific numbers in our equation. So here's the picture of the first part here. We've got a house shape drawn and we've got some points marked on there that are really helpful. So these points are E, B, C, A and F. And we're told that point C is up at 0, 9. And we're told that A and B are both points on this parabola, 9 minus x squared. And then E and F are on the x-axis. So I'm going to come back to all of those in a minute. What we have to do is to figure out how high we should build the wall of the house before we get to the roof part to make the area of the house shape a maximum, right? So what we're trying to maximize is the area of the house shape, so in 2D. So we want to maximize this. And then we have to justify that it's a maximum. So I haven't seen the schedule yet, but I'd say this bit is merit. What you're trying to do, or maybe it's excellence, I don't know yet, but you've got a rectangle and you've got a triangle. The other thing that really helps us that we're going to use is that the house shape is symmetric. So to maximize the area of the whole thing, I'm just going to work with two lots of half a house because this is maths, right? And actually that's just going to make things a bit cleaner. So we're going to have a little triangle here and we're going to have a rectangle here. So it's going to be convenient to put one more point in on there that we're going to be using quite a lot, and that's this point here, and I'm going to call that point D. Now, it's pretty funny that mysteriously there is no D on this picture. We've got A, B, C, and then E and F. So this one was, born to be D. There we go. Okay, so we'll do that part first. And then if you go slowly with that part, this next part looks really horrible, but it's actually not that much trickier. It's just a generalized problem. So instead of having 0, 9, we now have C being at 0D. And instead of having the parabola being y equals 9 minus x squared, we have y equals D minus kx squared. So D and K could take on any values. And we have to show now that the maximum area occurs when the area of the rectangular section here and the area of the triangular section ABC are equal. So what it comes down to is that we're choosing how high we want this wall to be. That wall is sitting on the parabola. So that means that it's linked up to this value here, right? So if I choose an x value, that means that the y value has to fit the equation y equals 9 minus x squared. So we're choosing a y value, but that's the same really as choosing an x value because they're completely linked up together. So I'm going to show you how to break this down into 8 steps now. And these are the steps, and they're the same steps we do for any kind of optimization problem at level 2. They should feel quite familiar if you're watching this video and you've done lots of practice questions already, or if you did last year's exam. Okay, so we need to start out by finding an expression for the area, and then we're going to get that to be just in terms of x, not x and y. We differentiate, we set to 0, we solve, and then we find the height y, and so we do this last bit. So the hardest part in these questions is usually this first bit, how do we get going? Right, let's have a look at this first part of the problem. So we need to find the area of the house. So the area is going to equal 2 lots of the rectangle. So we'll put point D in here. So that's OFAD. So there's O there. OFAD, plus the triangle, which is ADC. And remember, C is up at 0, 9. Now, you don't have to write it like that. You could have written something like this. especially because you're in a hurry. So 2 times the rectangle plus the triangle, that would have worked too. Right, now this point here, point F, has got coordinates x, 0. This point A has got the coordinates x and 9 minus x squared because it's sitting on the parabola. This length here is just our y value, right? So it's 9 minus x squared. And I'm just trying to find another colour pen. This little bit in here is the gap between 9 and the y value. We'll use all of that in a second. If I'm going too slowly, just put this onto double speed. But I've had quite a few students. Obviously, this is a pretty tough question, so I will go very, very slowly. So the rectangle just has coordinates, well, it has length times width, so x, y. And now the area of a triangle with a right angle is half the base here times the height. Right, let's just blow that up a bit. So the base here has got a width of x. And the height of that triangle goes from 9 to 9 minus x squared. So it's half times x for the base times 9, and I'll just make it 9 minus y for now. Let's expand that out and clean it up. We get 2xy plus x times 9 minus y, right? Because the 2 here and the 1/2 here cancel through. By the way, if you had just worked with half the area until the end and then doubled it and explained that that worked by symmetry, I certainly would have given you full marks. So don't worry about that too much. Then your expression would have not had this 2 in it, and it would still have had the half in here. So if you're watching this and feeling a little bit confused, that might be what's going on. So our area is equal to 2xy plus 9x minus xy, which gives us xy plus 9x. We can clean that up, right? We have cleaned that up, but we've still got y in there. We need to get rid of that y, and that's very easily done because y is equal to 9 minus x squared. So this area expression, which I'm going to call big A, is equal to x. Oh, that's what I'm trying to undo. Just a sec. Right, so we've got x times 9 minus x squared plus 9x. That gives me 18x minus x cubed. Right. So there could be a lot, sorry, I'll do that slower. 9x minus x cubed plus 9x. There we go. Now, if you look at where we've got down to, we've now got a really straightforward expression that we can differentiate. Let's go back to our steps and see how far through we are. Right, so we've done find the expression for the area, and we've done get the expression in terms of one variable. And you're probably going, whoa, we've still got 6 steps left to go, but they're really, really fast. The next thing that we do is we differentiate. So we write dA by dx is equal to 18 minus 3x squared, and that equals 0 for a max. So we have 18 is equal to 3x squared, 6 is equal to x squared, and so x is equal to plus or minus root 6. Now that does make sense for once in this case because we've got a value back here and we've got a value here. But we're working on the positive side of the axis, so we're going to use x is equal to root 6. Now I've worked with exact values the whole way through this question and I haven't got a calculator near me because we've just got home from camping. So I've just left it with x is equal to root 6. You can go and get that as a decimal approximation if you want to. Now, the next thing we have to do is to find the height of the wall. What we know now is that the maximum house area is going to happen when x is equal to root 6. And so we know what the y value is going to be. So the y value will be 9 minus x squared, which gives us 9 minus 6, which equals 3. The area of the whole thing now, so let's write some of that on. So this is 3 here. Okay, so the area is equal to 2 times my rectangle, which has area 3 root 6, and my triangle, which has area half, times the base, root 6, times the height. Now, that's drawn very not to scale. That height is going to be 9 minus 3, which is 6. All right, so we've got a whole lot of cleanup to do. So here we've got 6 root 6 plus a half times 6 root 6 times 2, right? So they go. So we've got the area is equal to 12 root 6. And again, go grab your calculator and work out what that is. Now, I don't remember if we were told units. Let's check. Well, it's probably meters squared if it's a house, right? But they haven't said. So we're fine. We can just put units squared. Obviously, if you're building a house, this is not much use to you, but it's nice to keep it in an exact answer until the very end. The very last thing that we've got to do, though, is to justify that it's a maximum. So 2 ways to do this. First of all, my area expression was 18x minus x cubed, right? So my first derivative was 18 minus 3x squared. Several ways to check the maximum, to check that it is a maximum. The fastest is to use the second derivative test, which gives us negative 6x, which is negative 6 root 6 for our value, so it's a maximum. But the other perfectly legitimate way to describe why it's a maximum is to point out that we've got an inverted parabola or an upside down parabola. So the only turning point is a maximum. Okay, so just like we've done all along, where we say, oh, it's because of the shape of the curve. The turning point must be a maximum. So that's the first part of the question done, and that's already taken me 13 minutes. I hope this is not too slow and boring. What I'm going to do is stop the video here, and then I'll come back and make part 2 that covers the generalised problem. So make sure that before you watch part 2, you've got all your working written down clearly for part 1, because it turns out that part 2 isn't really that much extra work, kind of. Okay, I'll be back in about 15 minutes.